Okay, y'all. So I'm trying a new program today for our videos. So you have to let me know if this works better or if it works better when I just film my PowerPoints. Okay? So today we are going to go over mutations. Let me write that down. Mutations. These are changes to our DNA. And we'll talk about later what causes them and what makes them good or bad. But in this presentation, I want to focus specifically on substitutions. Write that down. Okay. So when you hear the word substitutions, what do you think? What comes to my mind is I see right here is this word substitute. Kind of like this mean old woman right here. Okay? So a substitute is someone who tries to replace me. I know, not possible, but they sure try. They come in and they stand for me. Well, the same thing happens with our DNA. So let's go ahead and clear off the screen. And let's try a sequence and see if we can see what a substitution looks like. To make this ideal, you should have your own substitution, your own sequence of DNA. And if you're doing this in my class, you'll be working with one right now. And so you should walk along this process with me, doing exactly what I do to your sample. I know I talk really fast, so feel free to pause it at any point to catch up with me. Okay? Do that hard work, you can get this. So I'm going to write a sample of DNA down. Let's do 12 bases. Okay? Why do I do 12 bases? Well, because of my codons, it's got to, each codon is 3 bases, and I want it to have an even amount of amino acids. So if I have 12 pieces of DNA, and I divide it into sequences of 3 codons, this should produce a total of 4 amino acids. So let's clear that. I'm sick of the color green. Let's go with purple. Okay, so let's just start writing some down. I like C, G, T, A, C, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Kind of slant down there a little bit. Okay, 12. Hopefully there's no stop codons in there. I think I'm good. But we'll just watch out for that and deal with it if that happens. Okay, so right now this is DNA. Okay, first thing you would have to do is go ahead and change this to RNA, and from RNA to proteins. Today, I'm going to help you, and we're going to change this and say substitution happens. Something comes and doesn't copy just right in our DNA. So let's pretend we're going through, we're making RNA, so we start matching up. And C goes to G, G goes to C, T goes to A goes to U, C goes to G, G goes to C, T goes to A, T to A to U, G to C, C to G, T to A. Reminder, I'm using my U again because there's no A in RNA. Okay? But now let's say there's a mutation along the way, a substitution. Remember, back to this woman again. Okay? So with the substitution, someone's going to come in and take the place of another one. So I'm going to go here, and we're going to say this A is now a G. Okay? We've simply substituted it out, and we're going to change things. Because we're only impacting one spot, we're going to call this a point mutation. The reason is that this should impact just this codon right here. So let's see. Originally, we would have GCA, and now we're GCG. So I'm going to pull this up. Okay. Oops, I forgot. What was it? We have GCA, and we're changing it to GCG. GCG. Okay, so we've only impacted this one codon. So let's go ahead and use our codon wheel. We start in G, we go to C, and we go to A, and this will make us alanine. Now in my change, I go from G to C to G. Oh, we're still in alanine. We have changed our DNA, but our protein hasn't changed at all. Okay, we call this a silent mutation. Silent. Shh. It's silent because you don't see the impacts. Ultimately, it doesn't change our protein. Sometimes point mutations can, and in fact, I think it's sickle cell anemia that's caused by a single point mutation. But sometimes they're just fine. Sometimes point mutations cause good mutations, other times bad, other times like this, they're silent and there's absolutely no difference. So let's go back to our DNA. Excuse me. Back to our DNA. We changed one base. What should have been an A became a G, and it slightly modified our sequence. All that is with the substitution is you're replacing one with another. Go ahead and try this out with your sequence of DNA. Go ahead and walk it all the way through and change each of your codons into the proper amino acid to see the changes it makes. Some of the key points again to remember. Point mutation means we're only changing in one place. And if you don't see the impacts of it, we call it silent. A silent mutation is one you don't see any change at all in phenotypes because ultimately we use the same protein no matter which form we have. So let me know if you have any questions, but great work learning all about substitutions.